Hello, so this is the lecture for population growth and density dependence. And how I want to start out this lecture is by thinking about ecological models. Because in this class we'll be using ecological models more and more. So a lot of students ask, well, what's the point of these things? And the answer lies in what a model does is it simplifies a really complex system. Community ecology is one of the most complicated systems we have on the planet. There's potentially hundreds, thousands of species working together. I shouldn't even say working together, but working together, fighting against each other, eating each other, all sorts of different types of interactions. And what a model does is it tries to simulate what we find in nature by making a really simple system, reducing its noise, reducing the complexity. Then we compare those models to nature and see, does it actually explain nature? And if it doesn't, we can revise the model, make some changes. We can add mechanisms to make the model more complex. But what that does is it allows us to see what's going on, or test to see what is going on, to see if certain things conform to our model, or observations of nature conform to our model. Now, I've shown this little graph several times in different courses of mine, and it's a way to think about how models work. So think about over here on this model, where we have information here on the x-axis and then clarity on the y, right? So with increasing clarity there on that y-axis. Now, when we're over here, with very little information into our model, the model is too simple and it doesn't tell us that much. On the opposite then, if you have a model that is super complex, there's too many variables. You have a lot of information, but it's not very clear because there's just too much stuff going on. What we kind of want to do is hit this sweet spot, somewhere where the model has a decent amount of information that allows us to compare to nature and see what's going on. But still have some use to it, still have, it can't be too simple, because that's what we got over here. If the model is too simple, it doesn't really tell us much and we can't use it for anything. So we'll kind of start building some ecological models and hopefully get to this sweet spot here sometime during this class. Now in community ecology, right, we have different species interacting with each other. And to get to this kind of level, first what is good is to spend some time thinking about population ecology. And so kind of for a decent amount of this course or this lecture, we're going to spend thinking about models for population growth. Now, you've probably seen this in a variety of different courses where we have exponential growth versus this idea of logistic growth. And exponential growth, is this J-shaped curve where we see with time the population gets real big real fast, right? And everybody knows that this is not what reality is like. We do not have an ever-growing population. And we know that eventually populations have to kind of level out at something we call the carrying capacity. So what we see is that this exponential growth graph is too simple. It really doesn't tell us, we know that populations don't do this. The thing is, the logistic growth model is still really in this pretty simple category. We add a little bit of stuff, but it's still in the very simple models. But it's still useful, as we will see kind of throughout this class. All right, I'll come back in the next lecture, then spend some time thinking about putting these models together.